So based on this, there are two types of enthalpy change reactions. One is an exothermic reaction, one is an endothermic reaction. So what is an exothermic reaction?
Where energy is released.
If the energy released from the system to the surrounding, if energy is released from the system to the surrounding, it's an exothermic reaction. So if the net flow of energy, net flow of energy is from the system to the surrounding, we can call it an exothermic reaction. We can call it a exothermic reaction. If the net flow of energy is from the system to the surrounding, we can call it an exothermic reaction. So therefore, a system consists of the reactants and products. So if we have magnesium oxide plus HCl, it gives us magnesium chloride plus water. So the reactants has to always undergo bond breaking. They have to always undergo bond breaking in order to form new bonds. So reactants, in the reactant part, it's always the bond break, it's always bond breaking. And in the product part, it's always bond forming. Now, if the energy needed to break the bond, if the energy needed to break the bond is less than the energy released during bond formation, then it's going to be an exothermic reaction. So exothermic reaction is always the energy needed to break the bonds is less than energy released during bond formation. So net is it has a surplus of energy which is then left given out to the surrounding, and this is known as an exothermic reaction. So everything is based on the system. If energy is released from the system to the surrounding, exothermic reaction. If energy is taken in from the surrounding, it is an endothermic reaction. It's an endothermic reaction. So now we know that exothermic reaction is the energy taken in for bond breaking is less than energy released during bond formation. So exothermic reaction will always be negative. Why is it negative? Because energy is lost from the system to the surrounding. Endothermic is always positive. Why? Because energy required for bond breaking is more than energy released during bond formation. So, for example, if we need 150 kilojoule of energy to break all the bonds in this reaction, and the energy released is 100 kilojoule. The energy released during bond formation is 100 kilojoule. We still need 50 kilojoule of energy. We still need 50 kilojoule of energy. So where would we get this extra energy from? From the surrounding, right? From the surrounding. And how do we get this energy from the surrounding? From a heat source. From any heat source. So under lab, how do we heat an experiment, or how do we provide heat? Using a Bunsen burner, using a water bath, right? So Bunsen burner, water bath, these are all part of
Surrounding.
A surrounding. These are all part of a surrounding. So exothermic reaction, we know that when the reactants react to give us the products, the energy is released from the system to the surrounding. So overall, the system is losing energy. The system is losing energy. So that's why the system will have a negative value. So for an exothermic reaction, energy is released from the system. And what is the system made up of? The reactants and the products. So when energy is released from the system to the surrounding, we call it an exothermic reaction. And there's a small bulge. This bulge is for the activation energy. It's for the activation energy. So the activation energy should always be starting from the line of the reactants to the maximum point. So what is this activation energy? This is the minimum amount of energy which is required to start off the reaction. So activation energy joto high hobe, toto less feasible hobe. The reaction will be less feasible. The greater the activation value, the activation energy value, less feasible will be the reaction. Why? Because the reactants would be requiring to have more energy to start off the reaction. So activation energy, the greater the activation energy, the less feasible the reaction. So therefore, in an exothermic reaction, the activation energy is this much. But for an endothermic reaction, this is the activation energy. So you can see how high the activation energy is. So if you want to overcome this activation energy, what do you need to do? You need to provide heat from an external source. You have to provide heat from an external source. So external source would be from a Bunsen burner, from a water bath, any heat source is that external source. So when energy is released from the system, and what does the system consist of? The reactants and products. So when the energy flow is outwards, when the energy flow is outwards from the system to the surrounding, we call it a exothermic reaction. When energy flow is inwards, this is the system, this is the surrounding. So even from the graph, you can see that the system initially had less amount of less energy. And when it's forming products, it has more energy. So where did this extra energy come from? From the surrounding.
From an external, yeah.
From the external source. So when energy flow is from the external source into the system, it's an endothermic reaction. And when the energy flow is from the system to the surrounding, or from it's the energy flow is outwards, it's an exothermic reaction. So exothermic is most reactions are exothermic. Most reactions which will come across is an exothermic reaction. And endothermic reactions are respiration, sorry, not respiration, photosynthesis, then melting of ice. When ice becomes water, they gain energy from the surrounding, right? So that's endothermic. When water becomes vapor, they're again taking in energy. That is also an endothermic reaction. And then photosynthesis. So what are examples of exothermic reaction? Neutralization reaction. When acid reacts with an alkali, it gives salt and water. It's an exothermic reaction. Then opposite of melting and boiling, condensation, freezing. These are also examples of exothermic reaction. Then any combustion reaction, when you burn anything in oxygen, it's going to give us carbon dioxide and water. When you burn a hydrocarbon, it gives us carbon dioxide and water. That's also an example of an exothermic reaction. So calculating bond enthalpies, it will solve it as we do the question paper. It's very easy. Bond breaking. So enthalpy change is bond breaking minus bond forming. A minus B. So A minus B ultimately যদি negative আসে, it's exothermic. If A minus B is positive, then it's endothermic. Here we have done the calculation. So it's an example. This is from an O-level. It's from the O-level book, which you already studied. So here we have seen that the reaction is hydrogen plus chlorine gives us 2HCl. So the bonds to be broken in the reactant part is HH and ClCl. So the total energy needed to break the HH bond was 436. The energy needed to break the ClCl bond was 242. So the total amount of energy needed to break both the bonds was 678. And in the product side, the HCl, the number of bonds which needs to be broken is 2 HCl. So you need to break 2 HCl bonds, which is 431 into 2 is 862. So overall, 7 bond breaking, or E in minus E out. E in minus E out. So it's a negative value, which means that this is an exothermic reaction. It's an exothermic reaction. And this is for an endothermic reaction. Endothermic reaction, we can see that energy needed to break the bonds is greater than energy released during bond formation. So our overall value is positive. Our overall value is positive. So which shows that it's an endothermic reaction. Any questions?